Dr. Jess Wade is an Imperial College research fellow whose work involves investigating new materials for optoelectronic devices. When she isn't in the lab, she's involved in outreach work and is committed to improving diversity in science. She's written several biographies of women and people of colour scientists for Wikipedia. Melissa Castrillon is a British illustrator with Colombian heritage. She has a first-class honours degree in illustration and a master's degree in children's book illustration from the Cambridge School of Art. Her work, which is influenced by the art of Colombia, can be seen gracing the covers of children's books, including recent editions of Philip Pullman's His Dark Materials. She's also produced her own picture books, Mighty Min, and a gorgeous wordless book, The Balcony. Jess and Melissa join me today to talk about their joint project, Nano, a non-fiction book which makes advances in nanoscience accessible to young children and their adults. So a double welcome to you both today.
Thanks for having us.
And maybe we can start with you, Jess. How did you get into writing this book for children?
I got really excited about science because I had incredible science teachers. My parents are both medical doctors, so I was always kind of guided and supported into having a scientific career or into studying science. And then when I got to university to study physics, I really realized that actually not everyone had had that opportunity. You know, I look around me in the lab that I work in and I'm having the most fantastic time ever. I think I have the best job in the world, but we don't have enough people from different backgrounds there. It's kind of stuck science. It's still recruiting people that it's been recruiting for the last 100 years. So I've always had this kind of passion to get more young people excited about science. So we improve that diversity of people working in labs. And writing a children's book lets you tell that story about how exciting it is what you work on and take it to an audience that don't usually get it.
And this is going to be the starting point, hopefully, for so many of them. I want to come to Melissa now. Melissa, I've known your work for a while. I've got your beautiful wordless picture book, Balcony. I actually used it on a course that I was running with teachers the other day. So tell us a little bit about your background.
I've always loved art. I come from very much like Jess. My parents, my dad's a photographer and my mum has always been an art lover and very good at applied arts herself. So I've always been instilled with a love of art, and it was the only thing I ever wanted to do. It was the only thing I was good at. I never kind of had a plan B. I did study illustration at the Cambridge School of Art and I loved it. And then I went back and did an MA. So the BA was illustration and the MA is children's book illustration. And the MA was kind of life-changing, really. It's the first course. It isn't anymore, but it was the first course in the world that was specifically an MA in children's book illustration. So it has very, very good legs rooted in the industry. And yeah, I just loved it. I discovered screen printing and that changed my work a lot, and my love of traditional printing, which I try and carry through to the work that I do today.
I'll just ask you, because I don't know whether this is the case or not. I know that you've got some Colombian heritage.
Yes, my dad's
represented in your artwork in any way?
Yeah, well, my work took a big shift when I first went to Colombia. I didn't actually discover my roots. Like my grandma and my auntie, they all lived there, but I didn't meet them until I was 22, so about 12 years ago. And it was kind of like discovering half of myself that I didn't really know was there. And it kind of, definitely changed my work hugely. My love of colour, my love of just the natural world and pattern.
Excellent. So in the reading corner, we have representation from science and art. And what interests me is these are often seen or talked about as though they are diametrically opposite. I'm not sure that's actually true, though. What do you think, Jess?
I think it's very naive of us, and I think it's partly due to the education system. And hopefully a lot of teachers will appreciate that these subjects complement each other so much. You know, to be a successful scientist, you have to be creative. You have to think about putting together equipment in a new way to measure something that no one's ever done. You have to think about the way that you illustrate and design the figures, whether that's in your scientific paper or on a poster. You know, if we think about everything that's happened in the last year, the public health campaigns effectively conveying a scientific message using images is really hard to do if you're not remotely creative. And I think I realized it most when I was in Italy. I lived in Florence. But all of the Renaissance masters were scientists, they were builders, they were creators, they were architects, they were artists. And we kind of lost this idea that actually the two are incredibly beneficial. You know, thinking like a scientist, thinking logically when you're putting together a composition, or thinking creatively when you're trying to do a new piece of research is kind of fundamental to being successful.
I'm really glad I asked you that question, because your passion is coming through. It's emanating from the screen. What do you think from the other spectrum, though, Melissa?
Yeah, no, I 100% agree with Jess. Both disciplines, art and science, are there to aid in helping to explain what is going on in the world and helping to explain the world around us. They coexist with each other, for sure.
So the reason that we're talking about this today is because of your new book, which actually brings together the scientific with the beautiful aesthetic as well. And so, first of all, we should invite Jess to introduce the book. What really did you want to do here?
It's really a book about communicating how exciting science is, and particularly material science, and the kind of innovation that we can do now with chemistry and with physics and materials to design things that have incredibly interesting properties and serve the function that we want them to, and new technologies. I think there's a huge disconnect with what you learn at school about materials. You know, it's so solid, liquid, or gas. Okay, that's it. Close your books. We're done. It's not, we could actually manipulate a material to get it to do something incredibly complicated that would benefit society. And something that's always really excited me about the science that I do is the kind of societal and the real world impact. It's that you're making a new material that's going to make a more efficient solar panel that then we can put in some part of the world that doesn't have access to reliable electricity. Or you're making displays more efficient so our televisions and mobile phones don't consume so much power. And all of those kind of things I realized probably during my undergraduate in physics, or eventually during my PhD. And I think it's much more important to tell those stories early on, and to really tell the story of atoms and molecules and structures and chemistry, and give it a proper stage. Because when you look at the kind of children's books that you can buy, they're kind of primarily focused on astrophysics and outer space and the formation of planets, or weird and wonderful things in your body, or dinosaurs. And there's really not that much introducing the different sciences at all. So I thought chemistry and materials was getting kind of a bad rep, and you weren't learning about it until too late to have made any decision that that was something you were excited by.
Melissa, you've produced picture books and you've done glorious book jackets. Is this your first non-fiction text, and did you have to approach it in a different way?
It's actually my second. It's the first science book, and I was just surprised that they chose me, because the thought of doing an image without any foliage in it, because, you know, I love plants.
You didn't do images without, you managed to get some foliage in there?
The lab scene. That doesn't have any in it, and I was like, can I slip one in? Mm-mm. But the thing about Jess's text is that it's so visual. There's so much there for me to actually illustrate.
When you say it's so visual, can you give me an example of what you mean there?
Well, with graphene, the area in the book explaining the structure of graphene is so thin, and explaining it as if you made a tightrope out of graphene, an elephant could walk along it. And as soon as I read that, I was like, giant elephant, gotta do it. It makes it incredibly fun to illustrate, but also a tangible visualization of this concept and this material.
Were there any concepts that you did find it quite hard to illustrate? I
think trying to figure out the balance of, obviously you've got the little character, which I muddled on Jess. Actually, the initial drawings of the character didn't look like her, and Walker was like, could we make it kind of look like Jess? And so I kind of studied Jess a little bit and tried to make it look like her. But I think trying to get the balance of presenting the information as factual, but also having the character kind of shrink in size. So obviously that's kind of fantastical, and it's not something that would happen. So trying to get that balance of fun and factual.
I wonder, Jess, what about this kind of mixing of fantasy with science fact? Do you feel comfortable with that?
I feel so comfortable with it. I mean, the materials and the molecules that I work with are so small that we don't actually know what they look like all the time, right? I do all of these measurements and these investigations looking at how they absorb or they scatter light or how molecules might vibrate, but I only get the information as kind of a graph. We never see the individual molecules and how they're behaving. And so having this fantastical imagery and kind of approach to understanding it is almost what we do. It's just nowhere near as beautiful. So I think it's a massively important part of it. And if we just had outlines of a microscope or outlines of things that weren't remotely engaging or enticing, I think it would be hard to convey messages that are very, primitive, basic science. We're talking about atoms joining up and things like that. So definitely making it beautiful means that people will read it, but it also helps with telling the story.
There's a synergy between them. I'm just looking, for instance, even right at the beginning, where you talk about the properties of materials. It would be something light or something heavy, something strong or something bendy, something smooth or something rough. Each of these is perfect for a different job. You don't convey it in that way through illustration. You convey something else. So the language is definitely a really important part of that.
Science has this kind of, especially physics, this kind of pomposity and this need to use ridiculous jargon to explain things, when really, if you actually understand the subject, you have to explain it in the simplest way possible. And really, this is how I think about science. So I'm hoping that it's useful.
I love it.
That.
I think so many things exclude people by their language. And actually, not only in science, we try to almost make areas of knowledge so specialized that it keeps people out rather than inviting them in. And it's to the benefit of all of us to invite as many people in as possible. I tell you what, I think it would be really good to do. I'm going to share my screen with you because I've got a PDF of the book and it helps us get into some of the detail if we look at some of the spreads. So I thought if we each chose one, we could talk a little bit about what we saw in it, and it'll be interesting to see what comes from that. So let's start with your choice, Mel. Which spread should we talk about?
Spread 2. So you've got the girl on the left. On the right, you've got one of the female scientists looking through her giant microscope, and she's looking at the little character who I've kind of shrunk. And you've got Jess's wonderful text explaining about the material of a book and how the material of a book is perfect for what it's used for. If it was made out of stone, it'd be too heavy. If it was made out of glass, it would be too delicate. And if it was made out of chocolate, it would melt. It would be great if all books were made out of chocolate, but it wouldn't last long. I really enjoyed this. It was more because it was a challenge. It was a very factual page, and because I draw foliage all the time, I knew that I had to kind of dive in and do something a little bit more graphic and more scientific. It's very different to what I had done before. Yeah.
Can I just ask you from a technical point of view, were you keen to make sure that the apparatus of science was represented accurately?
Walker were very on my case about it, which is good. Like the lab scene went through a few guises. I tried to do the wires of the lab scene almost like vines, and they said that's way too messy. It needs to be way more organised, like a lab is. So I had to change that up. And I knew that scientists were going to look at it, and I didn't want them to kind of nitpick. So yeah.
I think that getting things right, that idea that you have to get the scientific equipment to look appropriate is just so important for the story. Having things that look like they do in a real life lab makes it so much more compelling, and also means that scientists can read it, also means that all these professors can give it to their children and can have those conversations.
Yeah. Jess, what would you like us to have a look at?
Definitely the lab scene, as Melissa alluded to in the answer. Definitely the scene of the lab where we have kind of the text that's housed in the molecular structure, which I just think is so absolutely perfect. For chemists listening, the text is in some benzene rings, and you can read all of the story. But around that, you have this kind of beautiful lab with lots of people doing different investigations on different pieces of equipment. And in the background, you have all of the different chemicals and structures that we might use. And the reason I love this the most is because of the people who are in it. Like, you see how many different kinds of scientists you have, scientists from all different backgrounds and scientists who are doing completely different investigations. And the best labs that I've been in have had a bunch of people. Sometimes no one knows each other when you start doing the experiment, all on different computers, using different pieces of equipment to look at molecules, to look at materials, to better understand structures. And you have these kind of very surreal conversations because you don't know each other, but you're both using this really high-tech piece of kit to do these experiments no one's ever done. And you're kind of working it out and saying, how do you do this? How do you do that? And I just love that kind of idea and that energy in this spread. I also think that it's just kind of beautiful and almost chaotic, but that's exactly how labs are. You never have enough space. I work at a university in central London, so we never have enough space in the lab to, really spread out our optical benches and do the biggest experiments possible. And we're always on top of each other. And I like that kind of comes in through this perspective in this spread. So I love it.
I want to have a look at a spread that actually deals with a concept that was new to me. So it's good to know that a book can work. It can work for somebody of my age too. So this is a page about, it's called the super sieve. And we have an incredibly vibrant picture taking centre stage. It's a pair of cupped hands. And inside that pair of cupped hands, we have your foliage, Melissa, 3 children drinking through straws, and there's the ocean, there's an octopus in the ocean. And then in the top right hand of the page, we've got a little insert which says inside a super sieve. And then it's labelled, as you often get inside it, but beautifully so, salt and dirt. I'm going to have to ask Jess to explain what a super sieve is.
It's a concept that we can make use of layers like graphene in these different ultra-thin molecular structures to do things beyond just conducting electricity or emitting light. We can actually use them to trap little particles of dirt or things that we don't want in it, almost like a filter, right? So if you're one of those very fancy people who has the water filter when they take water out of the tap, that's trapping some of the particles and the contaminants in the water. And the idea with this is that we can go one better because we can do it at a molecular level, and we can make use of those sheets and those structures that we've been introduced to throughout the book to really separate out different atoms and different molecules that we don't want in there. And the joy of this is that you discover a material like graphene, you discover some of these other kind of 2-dimensional molecular materials, and you have no idea when you discover them about all of the applications that they could have. And then you're speaking to a collaborator who works with people in the developing world, or then you're speaking to someone who works on water purification. And this could happen completely by chance, that you then think, oh, we can take this technology and we can use it to filter out all of the contaminants in water to provide reliable and clean drinking water to people in countries that don't have access to that. And I just love that. Like, you make something for an application, you have a really great conversation, and then it goes somewhere else. And I think this spread completely conveys the excitement and the wonder of that.
Absolutely. Can I just ask you, is there a kind of acceleration with which we're discovering materials like this now?
There's a complete acceleration, mainly aided by computation. So before, when you were trying to design a material or a new molecule, it would take years, right? You'd have very hit or miss synthesis. So chemists would spend 4 or 5 years trying to make something, trying to learn from published literature, but really struggling to do it. It's often really hard to reproduce these things reliably. So everything going online made it a little bit easier, but actually being able to computationally design materials to use a computer, and lots of people's jobs, full-time jobs, is this, that you use a computer to draw out and dream up molecules and then you run some programs and some codes to predict what it would behave like in a material. So you start off with kind of on their own molecules, like the atoms and structures you're introduced to at the beginning. And then you tell the computer to work out how it would behave if you put it into something else. And that's made it so much more efficient from a synthesis and a chemistry perspective, because you don't waste 10, 20, 30 years making something that after that is rubbish, because you start off with a plan of what's going to be brilliant. So it has completely accelerated, which is why we're seeing, you know, as we discuss in the book, things like the supersieve or personalized medicines or things like that, that we've never had the opportunity to work with before.
It's very hopeful in that respect. It gives us a lot of hope for the future.
Completely hopeful. I think science and art together will change the future, will make the future a much, much more efficient and sustainable place to live.
Now that you have got this partnership going over this wonderful book, I want to say that it's making me hungry for more. I think I might have mentioned to you earlier that typical subjects that crop up in the school curriculum to do with electricity, sound, light, the material that's available, you know, the written material, is so dull. And I would like to know what you think you could bring that might, you know, give us a little bit more excitement and joie de vivre in the whole thing.
I'll write any book Melissa wants to illustrate.
Yeah. Yes. I think there are so many subjects that people would think that are dry or publishers wouldn't touch with a barge pole, because publishers have to make money, and so they see stuff often through the eyes of how are they going to be able to sell this and make money out of it, which is understandable. So I think we've definitely got to kind of eliminate the idea that certain science subjects are dry and kids aren't going to enjoy it. I think we've just got to get out of the comfort zone of, like Jess said before, like dinosaurs and space and stuff that's interesting but is easily visually represented in an interesting way, and try and approach the things which need to be talked about.
And not be afraid to kind of push young people. I think that we completely underestimate the kind of things that they can and can't understand. And I think that this book really perfectly pictures it to say, this is obviously beyond what you're going to learn at primary school, but actually you can understand it, and we can do that by understanding it visually. And so I think a lot of the kids' books that I look at in science are just so patronizing. And, you know, we have to remember that often the parents are part of this learning adventure too, right? Most parents I've spoken to think they hate physics because they had a terrible teacher in physics 30 or 40 years ago, and they really didn't get that enthusiasm or that excitement. And so really it's kind of a science story for everyone. So I don't think there's any topic that can't be told in an interesting or a beautiful way. You know, that's why people work on these things, because they're so fascinating to study. So I think we shouldn't underestimate what young people are interested in. But coming back to Melissa's point about publishers wanting to make money, when I was first speaking to Walker, I went to an incredibly eminent material scientist, a professor called Mark Miodownik, to talk to him about writing it. And I was like, really just don't think I can do this. I was so terrified of being too simplistic and getting things wrong, and then having the entire scientific community being like, you got that wrong, you're completely wrong, it's too reductionist or whatever. And he said, don't worry about it. Publishers don't sell science books to make money. And I kept thinking of that throughout. But now I think like we've got something that's so perfectly pitched and beautiful. I don't know why everyone wouldn't read it. I can't imagine what kind of audience this wouldn't excite or inspire.
Can I just say thank you to Jess and to Melissa for joining me today. You've enthused me about this topic. I know it's going to be enthusing many young readers and their parents and their teachers. And I eagerly look forward to the next one as well. Thank you so much.
Thanks for having us.
In the Reading Corner is presented by Nikki Gamble and produced by Alison Hughes. If you have enjoyed this podcast, please do leave a review for us. To find out about other projects, including an audience with events and the Exploring Children's Literature Summer School, visit www.exploringchildrensliterature.uk. Join us again soon in the Reading Corner on your favourite podcast platform.